Hey scholars, I hope you all are doing great today and that you had a wonderful Easter break. For this lesson we are going to evaluate trigonometric ratios of special angles. So like 30 degrees, 45 degrees, 60 degrees, really any of those angles that you might see on the unit circle. We're going to practice finding those ratios. So make sure you're taking good notes, paying close attention. Let's get going. So when we find the trigonometric values of special angles, we are going to actually use the unit circle, what we've been learning about the unit circle, to help us to find these values. So just remember that any of these points, these coordinate points from these angles, they have a cosine value and a sine value. So for example, if you have 30 degrees, a 30-degree angle on the unit circle, well, that has a coordinate value of, let's see, square root of 3 over 2 and then 1/2. And you can see that right here on the unit circle. So remember, the cosine value is the x value. So the cosine, we would say, of 30 degrees is going to equal square root of 3 over 2. The sine of 30 degrees is going to equal 1/2 because it's the y value. So you have your cosine value and the sine value. So any of these angles has a cosine value and a sine value. They also have a tangent value. And we can say that tangent is sine over cosine, or y over x, because sine is y, cosine is x. Check this out. Here's why we can say the tangent is sine over cosine. So the tangent of theta is sine of theta over cosine theta. So remember that sine is opposite over hypotenuse and cosine is adjacent over hypotenuse. So I'm saying opposite over hypotenuse over adjacent over hypotenuse here. So let's write this out horizontally instead of vertically. We would say opposite over hypotenuse divided by adjacent over hypotenuse. Well, when you divide fractions, you keep, change, flip, right? So we're going to say opposite over hypotenuse times flip, right? Hypotenuse over adjacent. Well, the hypotenuses are going to cancel out, and then we're left with opposite over adjacent. Well, isn't that what tangent is? Tangent is opposite over adjacent. So we can say that tangent of theta is sine theta over cosine theta, or tangent theta is y divided by x, the y value divided by the x value. Remember when we talked about reference angles a few lessons ago? Well, I told you they would come back and we would use them. We're going to use reference angles to find these trig values. So here's an example of how to find the exact value of sine and cosine of negative 30 degrees. You can look at this example on your own on the slide, but you really want to make sure you get these steps down. First, what we're going to do is draw the angle and find the measure of the reference angle, okay? So for a negative 30 degree angle, you're going to draw the reference angle, so for a negative 30 degree angle, you're going to draw the angle, and then you're going to determine the reference angle. So the reference angle, remember the distance from the x-axis, right? Well, the reference angle is going to be positive 30 degrees. It's 30 degrees away from the side of the x-axis that it's closest to. So what we're going to do next is we're going to use that reference angle. We're going to use the values, the sine and cosine values of 30 degrees. So the sine of 30 degrees is 1/2. The cosine of 30 degrees is square root of 3 over 2. Okay? And so remember the sine value is the y value. So in this quadrant, negative 30 degrees is in this quadrant, right? So in this quadrant, the y value is negative, we're in the fourth quadrant, and the x value is positive. So for sine of negative 30 degrees, you can see that since the y value is negative, the sine value is changing to negative 1/2. And since the x value is positive, cosine of negative 30 degrees just stays at square root of 3 over 2. All right, so let's work a few problems. We're going to use the reference angles to evaluate these ratios. We're going to get some practice with this. Okay, so first one we have is sine of 135 degrees. So what I'm going to do first is I'm going to draw the angle, just like we've practiced in the past. So 135 degrees, I'm going to go 90 degrees, and then another 45 degrees in this quadrant. So here we have a 135 degree angle, and don't forget your initial side as well there. So our reference angle is going to be 45 degrees. It's 45 degrees away from the x-axis. So we're going to look at the sine and cosine of 45 degrees. Remember, 45 degree angle has coordinates of square root of 2 over 2 for the x value, the cosine value, right? And the sine value is going to be square root of 2 over 2 as well. Okay? But we are in the second quadrant. 135 degree angle is in the second quadrant. So we need to ask ourselves, we're looking at the sine value, right? So I'm not worried about the cosine. We're looking right here. Is the sine value going to stay positive or is it going to be negative? Well, is the y value positive or negative in the second quadrant? Well, it's positive. So the value is going to stay positive, and your final answer, sine of 135 degrees, is just going to equal the square root of 2 over 2. Okay? So I'm going to clear that off, and I'm just going to write that answer right here. Sine of 135 degrees equals the square root of 2 over 2. All right, let's do the same thing for cosine of 3 pi over 2. Well, cosine of 3 pi over 2, you say radians here, right? That's going to be the cosine of how many degrees? Well, 3 times 180 is 540 divided by 2. That's going to be 270 degrees. Okay? So, 270 degree angle. Let's see here. I'm going to draw that. And I'm going to go 90 degrees, 180 degrees, 270 degrees. Well, this is a little bit weird here. What we have is the terminal side is actually falling along the y-axis. So you should already know this from your unit circle. The point right here, since the radius of the unit circle is just 1 unit, we're going down 1 in the y-axis, and we haven't gone to the left or the right. So the coordinate point here is 0, we went 0 in the x-axis, and down 1, so negative 1 in the y-axis. So that's the x and y values here, the cosine and the sine values. Well, what is the cosine value here? That's the x value, right? So we're looking at 0. So the cosine of 270 degrees actually equals 0. Crazy, right? So there we go. That's how we find the cosine of 3 pi over 2 radians. Now let's look at number 3. Tangent of 4 pi over 3, again, radians. Should have included that. Well, 4 pi divided by 3. 4 times 180, that's 720. Divide that by 3, that's 240. So we'll say the tangent of 240 degrees. Let's draw that. I'm just going to draw it up here because I have some space. So we're going to go 90 degrees, 180 degrees, and another 60 degrees. All right. So that's a 240 degree angle. Let's draw that initial side. I think I actually forgot that on here as well. That's all right. We got a 240 degree angle. How far are we from the x-axis? What's our reference angle? Well, that reference angle is going to be 60 degrees. So what are the coordinates on the unit circle of a 60 degree angle? They are 1/2 square root of 3 over 2. And you may want to look at your unit circle. That's why we practiced memorizing that last class. Those are the coordinates of 60 degree angle. All right, so this is when we're in the first quadrant though, right? 60 degree angle is in the first quadrant. But we're in the third quadrant. That reference angle is in the third quadrant. So the x value is negative and the y value is negative. So for 240 degrees, let me change this here. For 240 degrees, these are both going to be negative. Now, we're talking about the tangent of 240 degrees. Remember, tangent of an angle, so 240 degrees in this case, is going to be the sine over the cosine. Well, sine is negative square root of 3 over 2 divided by negative 1/2. So I'm just going to go over here and write this horizontally. We got negative square root of 3 over 2 divided by negative 1/2. I'm going to keep change flip, negative square root of 3 over 2 times negative 2 over 1. Negative times a negative, that's just going to cancel out. I'm just going to go ahead and get rid of the negatives just to make this a little nicer looking. Now, we can cancel these 2's diagonally. So we get square root of 3 over 1, which is just the square root of 3. So the tangent of 4 pi divided by 3 radians, or 240 degrees, is going to be the square root of 3. And let's box that. Now let's do this last one, cosecant of 60 degrees. Remember, cosecant is the reciprocal of which ratio? That's right, sine. All right, so we're going to find the sine ratio of 60 degrees and just flip it over. Okay, so when we have sine of 60 degrees, then we know that that's, so when we have a 60-degree angle, we know the coordinate points are 1/2 in the square root of 3 over 2. Okay, so the sine value that we want to look at is square root of 3 over 2. So cosecant is the reciprocal of sine. So cosecant of 60 degrees, you're going to look at square root of 3 over 2, and I'm just going to flip it over. That's going to be 2 over square root of 3. Now again, remember, we don't want to leave a radical in the denominator, so I'm just going to rationalize that. 2 divided by the square root of 3, I'm going to rationalize it by multiplying by the square root of 3, numerator and denominator. That's going to give me 2 square root of 3 over square root of 3 times square root of 3 is just 3. So the cosecant of 60 degrees is 2 times square root of 3 over 3. So I hope that video was helpful for you. If you feel confused about anything, be sure to re-watch parts of it and come to class ready with questions. I'll see you then. Good work today. Thank you, Collegiate Scholars.